Okay, now let us learn about the equations to find the charge, voltage, and current for both charging and discharging process. Okay, first of all, I want you to recall back what is the changes for that happens for charge, voltage, and current in both of these process. Okay, for charging process, okay, let's look at the charging process. For the charging process, the charge and voltage increase because it's like the water tank from from empty become full. Okay, so the voltage, the charge and the voltage increase. But for discharging process, the water from full become empty tank. So it's just like the charge and voltage both decrease. Okay, both decrease. But for current is different. Current for charging process, current from charging process is from maximum go to zero. Why is like that? Because it's like initially it has a lot of water flowing into the capacitor. You can say a lot of water flowing into the water tank. When the water tank become full already, the water stop flowing. Okay. So it's just like initially before the capacitor is being charged, due to the high potential difference, so the current will flow very violently. Yeah, the current will flow vigorously in order to charge up the capacitor. But once the capacitor is being fully charged, no more current flow. So that's why initially the current is maximum. Yeah, the current for charging process. It start from maximum because the charging process is very vigorous at initially. But when the capacitor is almost fully charged, the current will drop. Will slow down until the capacitor is being fully charged. When the capacitor is being fully charged, the current stop flowing already because it's already fully charged. When fully charged, no more current flow, flow to charge the capacitor anymore. The current stop flowing. Okay, the current decrease. So for charging process, only the charge and voltage increase, but the current decrease. Okay. Not everything increase, not the current increase, not the current increase to charge the capacitor even more. Yeah, no, the charging process will slow down. Yeah, when the capacitor is almost fully charged. Okay, so for charging process, only the charge and voltage increase, current decrease. That's important. Now for discharging process, we know that the charge and voltage decrease, but the current also decrease. For this one, the current also decrease. Why current decrease? Because initially it has a lot of water, so there's a lot of substance flowing out, a lot of water flowing out. So the current is maximum, flow out maximum because of a lot of water flowing out. But when it become empty tank, no more water flowing out. Yeah, no more water flowing out. Current becomes zero. Yeah, so it's just like when the capacitor is fully charged, so the discharging process, the current to discharge the capacitor is very high. But once the capacitor almost discharged, is fully discharged, when the capacitor fully discharged already, no more current flowing in the circuit already because the discharging process already stopped. Okay? One thing to remember that very important, very easy to remember why current decrease for both process is the current will stop flowing. The current will stop flowing when the charging process stops. The current also will stop flowing when the discharging process complete. Understand? The current will decrease. The current will decrease for the charging process. Yeah? During the charging process, the current decrease because the charging process almost complete. For discharging process also, the current will decrease because the discharging process almost complete. Okay? Almost complete. Okay? Now, so look at the one thing for the formulas. What's the formula? Yeah. So if you look at this, you can see a similarity. Yeah. For those formula that you have the value increase, the formula is 1 minus epsilon. 1 minus epsilon. 1 minus epsilon. You see, for charging process, the charge and voltage increase. So they have the formula 1 minus epsilon. But for all other quantity that decrease, like this one, the current here decrease, voltage decrease, charge decrease. For all the others, use epsilon. You see, epsilon. You see, only we can say only these two. Only these two has 1 minus epsilon. But for all the others, use epsilon. Why? Why this one you all use epsilon only? Because they have decreased. They decrease. Their quantity decrease. Okay. This one 1 minus epsilon because the quantity increase. Okay. Good. Okay. Now I want you to look at here. The formula actually negative T over RC. Negative T over RC is actually the power of epsilon. The power for epsilon is the same. Negative T over RC everywhere. Okay, negative T over RC everywhere. Now here we have if charge of capacitor is Q naught, voltage capacitor is V naught. Is here all Q naught, V naught, I naught, Q naught, V naught, I naught. Now for this V naught and I naught, they have relationship. V naught is actually I naught times R. V naught is actually I naught times R. You actually can see from here. Last time, if you look at my first video, I already explained how do we get V naught equal to how do we get V naught from I naught. You use the V equal to IR. Yeah, resistor here. I naught times R, we have V naught. From here. Okay, from here. V naught equal to I naught times R. Okay, from here. Okay, so V naught equal to I naught times R. Same goes to this one. V naught equal to I naught times R. You see these two formula. This one is positive current. This one is negative current. You still remember why the charging and discharging process? This one positive current. This one negative current. I already explained before. Yeah. This one because this one is opposite direction compared to this one. This one is anti-clockwise. This one is clockwise, isn't it? Because charging process, and discharging process, the current flow in opposite direction. Okay. Now enough for that. Now I want you to look at one more thing. This is very easy way to remember. Very easy way to remember. If you want to remember the equation for each process, you just remember for charging process. Is we know that the charge increase, voltage increase, but the current decrease. Okay. And then for the discharging process, we know that the charge of capacitor decrease, voltage of capacitor also decrease, current also will decrease. So what's the formula? For the one increase, use 1 minus epsilon. 1 minus epsilon. Yeah, these two use 1 minus epsilon. But for all the others, you use epsilon, 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 epsilon. See, the current for charging process is decrease, is epsilon. The 1 minus epsilon is not for all. It's only for charge and voltage for charging. But for the current, it's always decrease for both process. The current always decrease for both process. So use epsilon. Okay, enough. So that's one easy way to remember. Now I want you to know about time constant. Time constant is actually time. Yeah, time, it has unit second. So time constant, actually the formula is RC. It means the resistance times the capacitance. You get the time constant. Anyway, what is time constant? Time constant actually is a time to reach a certain value. Yeah, to reach a certain value. So since the time constant equal to RC, equal to RC, so we can substitute. You see here we have RC. Do you notice the formula? We have RC here. We have RC here. We can substitute this RC with time constant. So for all the formula, we can actually change the RC become time constant, become the tau. Yeah? Actually, the Greek word is a Greek letter for T, tau. Tau. So the RC below we can change to the time constant. So for each of these, we can change it to negative T over tau. This one also negative T over tau. That means we can actually write the formula as, like for example, this formula I can write as Vc equal to V naught exponent negative T over tau. T over time constant. You understand that? I can write. Same goes to all the other formula. Alright? So now, what's so important about this time constant? It's a very important value. You must know the definition. That's the formula to find the time constant, but the formula itself is just for calculation. It's just for calculation. You cannot use T equal to RC to define time constant. That's not the definition of time constant. That's only for calculation. To define time constant is actually this sentence. And you also can understand the time constant from the graph itself. Time constant is the time taken to reach a certain value for each of these process. So you see how many process you have? You have 1, 2, 3, 4, 5, 6. You have three graphs for each process. You have 3 graphs for charging, you have 3 graphs for discharging. So you have 3 definition of time constant for charging process. You have 3 definition of time constant for discharging process. Depend on what you want to explain. Yeah, depend on what the question asks you. Okay. So you have a total of 6 definition. Actually, your total have 6 definition of time constant. So how to explain the definition of time constant? Just use the graph. Time constant is the time taken for the charge for the charging process. Time constant is the time taken for the charge to increase to 0.63 of the maximum charge during the charging process. Time constant is also the time taken for the voltage to increase to 0.63 of maximum voltage during the charging process. Time constant is the time taken for the current to drop to 0.37 of the initial current, initial I0, during the charging process. Time constant, as I said, you have 6 definitions. Yeah. Now the 4th definition, time constant is the time taken for the charge to decrease to 0.37 of the initial charge during the discharging process. Time constant is the time taken for the voltage to decrease to 0.37 of the initial voltage during the discharging process. Time constant is also the time taken for the current to drop to 0.37 of the initial current during the discharging process. So I have mentioned 6 different definitions of time constant for both process. Okay, which is explained by this. How do you get? Just now I did mention I did mention about 0.63 and I did mention about 0.37. Why like that? Why we have this? In fact, if you look at here, you have one similarity. The one with increase, like the charge and the voltage, use the 1 minus epsilon for charging process. You have the value 0.63. But for all the others, which decrease, which uses the formula epsilon, they all uses 0.37. Do you see the similarity? The one minus epsilon, you will have 0.63. The one with only epsilon, you will have 0.37. Okay. Now, So how do you get this value? First of all, how do you get this 0.63 and 0.37? Very easy. Very easy. You just substitute when time equal to time constant. Now I come to the definition part. When time equal to time constant, that means, you know, the formula here, we have the time here, isn't it? We have the time here. Now I'm taking the charge. I'm taking the sorry. Now I'm taking the charge for charging process. Yeah, charge for charging process. The charge formula for charging process. That means I'm taking this formula. I'm taking this formula. Charge for charging process, which increase this one. Okay. Now when time equal to time constant, what happened? That means I substitute the time here. I substitute the time here with time constant. I substitute the time here with time constant. So the time here just now, I substitute already with, you know, here. What I mentioned is here. Here, this place. Yeah. I substitute here this one, or we can say this one. I substitute this one with the time constant. You understand that? I substitute with time constant. Below already time constant because it's RC. Below is RC is time constant. Okay. So I substitute. Alright. This one is already time constant. So now when time equal to time constant, so time constant. So both can be cancelled out, isn't it? Both can be cancelled out. So it become 1. Time constant over time constant, you get 1. So exponent negative 1 is 1 over epsilon. 1 over epsilon. So 1 minus 1 epsilon. You press your calculator. If you don't believe me, you press the calculator, 1 minus 1 over epsilon, you will get a value 0.63. Or almost this value, 0.63. What is mean by 0.63? Actually is 63%. So what is it mean by this? So what does it mean by this 63%? That means when time has reached the value of time constant, the charge of capacitor, has already been charged up, has already increased to 63% of the maximum charge already. It's just like you charging your handphone, you know, you're charging your handphone. How much time it takes for your handphone charge to increase to 63% of the maximum charge, maximum storage of your phone. That's the meaning. Okay. How much time it takes? Maybe your handphone is fast charging. Maybe your handphone is fast charging. That's very good. Okay. How much time does it take for when your handphone is empty? Yeah. Let's say already no more battery. Now you take your handphone to you take your handphone to charge lah. You take your handphone to charge. How much time does it take from zero charge to increase to 63% of battery? How much time it takes for the handphone to charge from zero charge up to 63% of the maximum charge? That is the time constant. The time taken for the capacitor to charge from zero charge up to 63% of charge, the time that has been used to charge from 0 to 63%, that is the time constant. That is the time constant. How much time it takes for your handphone to charge from zero charge to 63%? 63%. That time you have in mind is the time constant. Okay. So time constant is the time taken for the charge of capacitor to increase to 0.63 or 63% or 1 minus 1 over epsilon. You can either use these three. Yeah? You can use this or use this or use this. Yeah, normally we use these two. 1 minus 1 over epsilon or 0.63. We use this one. To increase to 0.63 of the final maximum charge, which is Q0 during the charging process. Okay. For voltage also, because we know that the charge increase, that's why I use 0.63. Voltage also increase, that's why also 0.63. But for the current, the formula is using the epsilon. But voltage just now is 1 minus epsilon, that's why also 0.63. But for the current is epsilon formula. Epsilon is decrease, decrease 0.37. Well, how do we get this 0.37? Do again the same thing. Maybe we take this formula. Okay, for discharging process, use the epsilon formula. Okay, use the epsilon formula and use this formula and try and calculate and see. Put the time constant there. So cut off. We get 1 over epsilon. 1 over epsilon. Press your calculator. 1 over epsilon is 0.37 or 37%. So for this discharging process, what is the mean by this one? Time constant. Time constant is this is the definition of time constant. The time taken for the charge of capacitor to decrease to 37% or 0.37 of the initial charge during the discharging process. That means let's say you have a handphone with maximum charge. You fully charge your handphone. So how long does it take? How long? The time constant. How long does it take for your handphone to use, you calling, play games? How long does it take for your handphone to discharge to only 37% of battery left? That's the time constant. Okay? That's the time constant. How long does it take for the battery to decrease to only left with 37% of the battery? That's the time constant. Okay? So say that's how we get 0.37. So same goes to this current here, 0.37. So all these we know for discharging process all decrease. So that's why all 0.37, 0.37 all decrease. Okay, I think I have finished everything. So depend on the question. You must be careful with this definition. Yeah, one thing is time constant equal to RC is not the definition. It's just for calculation. You cannot use this as your definition. You must use either 6 of this definition as your answer for when asked about definition. So for this, when the question asks about definition, you must look whether it is a charging process or discharging process. Is it referred to only the charge or the current or the voltage? So you must answer your definition for time constant according to what is asked in the question. It asks for charging or discharging. Don't the question ask for discharging, you give the answer in charging process. That's wrong. Understand? So be careful what the question asks. So there are total of 6 definitions of time constant for you to choose. One very easy way to explain the definition of time constant, just look at the graph. Time constant is the time taken for the charge to increase to 0.63 of the maximum final charge Q0 during the charging process. Time constant is the time taken for the charge to decrease to 0.37 of the initial charge during the discharging process. You need to mention during what process? Is it during charging process or is it during discharging process? These are the things you need to pay attention. Okay, that's all for charging and discharging capacitor. I have taken a lot of time of you. Thank you for watching and patience. See you for the next videos. Bye.